Hello and good day to all of you. I want to take a very short time to solve this question. It falls under the more about vectors, what we did in the previous video. Yes, so in the previous one we established that when you have vectors acting at right angles to each other, then their resultant should be what? The hypotenuse. So we can use the Pythagoras theorem to find the resultant, the magnitude of the resultant, and then we can use our cosine or tan, preferably tan, to find the angle the resultant is making. It can be relative to either the horizontal or the vertical. Okay, so let's go on. So here a load is suspended from a thread, as seen in the video here. Okay, so I have to just put that down. So it's suspended from a thread. Now the vertical force of the thread or on the thread due to the load is 0.75 Newton. Now what's the mass of the thread? So since it's vertical, it's acting in the the earth gravitational field, and so we can use the formula weight equals mass times strength of gravity, whereas mass will be the weight. In this case, that's the force because it's hanging vertical. 0.75 over our g, the strength of gravity. So preferably use 9.8. So 0.75 over 9.8. That's giving us 0.077 to two significant figures. So 0.077, and that's in kilograms. So that's it, first one done. And they are saying the figure 1.1 shows the load suspended from the thread. So we can see it over here. A wire is attached to the load at point X and pulled horizontally to the right. So the tension, so because this load weighs 0.75 Newton, and so there's going to be a force of 0.75 Newton vertically downwards in this direction. And they said we attach a wire to point X, so we attach a wire to it, then pull it horizontally to the right like this. And so they said the tension in the wire is 1.2 Newton. Now vertically, the force or the weight acting is 0.75 Newton. Now a force is acting downwards, another force is also acting to the right at right angle to each other. Then we expect the load to be displaced in this direction. So you see the direction of the resultant. I think some of you drew the resultant like this. Once you're having this and this, then just connect it. No, you have to always see how we read and analyze the question, then we know the direction of the resultant. Then in that case, they said by drawing a scale diagram or by calculation. Of course, you can do a scale diagram drawing to get the magnitude of the resultant. We'll talk about that later. But in this question, let's just focus on the calculation. What's the magnitude of the resultant of force at X? due to the load and due to the tension. So due to the load, due to the tension, the resultant will be this, the hypotenuse that is being formed from the force due to the load and the force due to the tension. Also, what's the direction of the resultant relative to the vertical direction? So by here we are taking the direction to the vertical. Okay, so this is the resultant R. Quickly we write that our resultant is the square root of adjacent squared plus opposite squared. Since they are adding, we can just write them in no particular order. So 0.75 squared plus 1.2 squared, and that will be the square root of 0.75 squared plus 1.2 squared. Two significant figures, the resultant is 1.4 Newton. So the load is going to experience a resultant of 1.4 Newton in this direction. Now the direction of the resultant relative to the vertical. So this angle we are looking for. This is the opposite, this is the adjacent. So for the direction, tan theta is equal to the opposite, 1.2 over the adjacent, 0.5. Don't forget, if you don't locate your direction or the angle correctly, you may switch this. You may rather have your 0.75 as your opposite and 1.2 as your adjacent. So quickly, our angle is tan inverse of 1.2 over 0.75. For accuracy, you can just put all of them into it directly. So shift tan of the fraction 1.2 over 0.75. No. 57.9, that's 58 degrees. So it's making an angle of 58 degrees to the vertical direction. If it were to be the horizontal direction, the angle will have been different. If the angle were to be here, then that means this will be the opposite, this will be the adjacent, and we'll get 58 minus 90 minus 58. I think that will be 32 or 22. So if you switch it, you are going to get 32 degrees, which wouldn't be the direction of the resultant relative to the vertical. It will be relative to the horizontal. So always take note. Yes, so we just do this for 4 easy marks. Okay, now for the second question, same application. I took it from the sub question under a full question. So show the direction of two forces acting on the different balloon as it moves. So we have 0.4 to the right, 0.74 to the left. Now the resultant is going to be in this direction. But if this force pull it to the right and this also pulling it downwards, it is going to move in this direction. Of course, for these people just drew this as a resultant. That is not right. So they say determine the magnitude and direction of the resultant force on the balloon. Here they didn't tell us whether it should be to the vertical or to the horizontal. Preferably we can choose to the horizontal. If you choose the horizontal, then we are going to state that this is the angle relative to the horizontal, or the 0.40 Newton. If you also choose this, then you also state that there is an angle relative to the 0.74 Newton force. Okay, so if I have this here, this force 0.74 will be parallel to this, and so it completes the triangle. So I'm having 0.74 here, and I'm having 0.4 here. So quickly, my resultant is square root of 0.4 squared plus 0.74 squared. You shouldn't use more than 10. Am I saying 10? More than 2 minutes on this question. So square root of 0.4 squared plus 0.74 squared. 2 s's. The resultant is 0.84 Newton. And the direction, if I pick this, then my tan theta is going to be equal to opposite 0.74 over the adjacent 0.4. And so my direction will be tan inverse of 0.74 over 0.4. I just put that directly into it. Shift tan 0.74, no, 74 over 0.4, 61.6. That will be 62 degrees to the horizontal, or the which one is the horizontal? 0.4 Newton force, right? If you did it the other way, then you are going to be getting 28 degrees to the vertical. Yes, it is also right. Because we've not been told what to do, whether to the vertical or horizontal, we are choosing it by writing the correct reference for the direction. Yes, so the same application over here, less than 2 minutes should be gone. Just know that river current is like this. A swimmer starts at point P, constant speed relative to the water at right angles to the current. So they are going to be moving like this. When you start here and the river is moving like this, or the river current is to the left, then you are going to end up here. So they say to determine relative to the bank or the river bank. So we want the magnitude and direction of the swimmer's velocity. So we want the swimmer's velocity, the direction should be relative to the bank of the river. So the angle should be here, relative to the bank of the river. That means I'm not going to use this triangle. You can also use it, then later you do a subtraction from 90. But to make it easier, since this will be parallel to this, then this is a triangle, the right angle triangle I'm going to be working with, so that the constant speed is 0.72 and the river current is 0.54, which means this adjacent is also 0.54. So quickly, the resultant is the square root of 0.54 squared plus 0.72 squared 0.54 squared plus 0.72 squared. 0.9, right? Yes. So the resultant velocity is 0.9 meter per second. Then the angle relative to the bank of the river. So my tan theta is the opposite, 0.72, adjacent 0.54. So the angle is tan inverse of 0.72 over 0.54. Very quickly, tan inverse 0.72 over 0.54, 53. So it's 53 degrees relative to the bank. They already mentioned it. So 53 degrees is my answer relative to the bank. Now there's a sub question. At 1.5 minutes, the swimmer reaches point Q. What's the distance between P and Q? So we are talking in terms of velocity, and so distance is equal to speed times time. Now what's their resultant velocity? We just calculated 0.9. Now the time we change to seconds. 1.5 times 60 seconds. So we'll have 0.9 times 1.5 times 60. That is 81 meters. So they have traveled 81 meters in 1.5 minutes. Okay, same scenario. The boat points at right angles to the river bank and it travels at 3.5 relative to the water. So they say the boat is crossing. So it's moving 3.5 meter per second. The river current acts at right angles here, so you know you are going to be using Pythagoras. To the direction the boat points, the river current has a speed of 2.5. Okay, so they just told us they are at right angle, they are perpendicular. So we can put it here. 2.5 meter per second. Over here to the said what? So by skill drawing or by calculation, we are using calculation, the speed, the direction of the boat relative to the bank. And so if this is a resultant, then this is going to be the angle relative to the bank. And so we are going to be using this triangle, this. So what will be the opposite? Is the same value here. So because they are parallel, 3.5. What will be the value here? Parallel to this, so this is also got 2.5. And so the resultant will be square root of 2.5 squared plus 3.5 squared. That's giving us 4, so it's over here, 4.3 meter per second. I include my units. And the angle, this is the opposite, this is adjacent. So tan inverse of 3.5 over 2.5. Tan inverse of 3.5, 2.5, 54. So that's 54 4 degrees to 2 SFs. Speed is a scalar quantity, velocity is a vector. Yes. State the names of one other scalar and one other vector. So scalar quantities: time, mass, length, energy, temperature, so on and so on. Vector, we have momentum, force, and a whole lot. So I just supposed to state one, and yes. So all right, so thank you for joining for this question solving session. I'll see you in another one.